The internet computer is um, conceived as an extension of the internet that allows the internet to host software. So the internet has been, a transformational and seminal invention in the history of man, and it really came into being in 1983 when Vint Cerf and his partner, I forget his name, invented TCP/IP, and then it grew very quickly in the 90s and became the internet that we all know today. Now, the internet um, connects software. So it connects your web browser on your laptop to a web server that gives it the content. It connects your WhatsApp client to another WhatsApp client, or a Zoom video call to another one, and so on. And that's been its purpose. But today, the network doesn't do compute. It connects you to services that are running software. So the idea is that the internet can be extended so that, as well as connecting software, it could host software, and that's only part of it. So one of the really cool things about the internet is that it's decentralized, and the underlying science makes sure that some of the roots go down on the internet continues running, and that the history of that has roots in the Cold War, and work in the 1960s. Bell Labs and places like that to design packet switching networks that would continue providing communication services in the event of a nuclear war. And that's why, of course, we've seen some undersea cables being pulled up recently, and the internet always continues running brilliantly. And so, when thinking about like how if you have an internet computer, um, you also have to, you also want to introduce some of these kind of fantastic properties, and um, there's a lot of complex computer science that goes into making the internet computer work. But um, for example, when you run software on this network, it's tamper-proof, so it doesn't need protecting by traditional cybersecurity measures like firewalls and anti-intrusion software and anti-malware. Within the fault bands of the network, it's unstoppable, so you don't have to worry about your software crashing and needing restarting. And you can also do things that you can't do on a traditional platform. So software can be autonomous, which means it can run without a human owner, or it can run under the control of a digital governance system. And a lot of work has been done to reduce um, some of the hidden costs involved in compute. So one of the biggest is um, the time involved in creating new software systems like web applications and internet services. And the internet computer supports a new kind of serverless software that greatly simplifies actually the implementation of some of these things. And a big emerging focus is, how do we enable AI to build solo? So there's this vision for the of a self-writing internet, and a self-writing internet is one where you can talk to the internet or talk to an AI that might be running separately or as part of the internet, and it completely solo will create web applications and internet services and so on, and also allow you to update them in production just through more talking. So there's that, and we were addressing that by
It
leveraging.
makes sort of everyone a web developer in a way. Anyone
Yeah.
can build it, or a software developer. Anyone can build their own software, have it hosted. The software is hosted on the internet computer, but because you have that sort of large language model interface to it, you don't have to be an expert in the protocols of the internet computer to build software on the internet computer.
Yeah, so the idea is that 8 billion people are empowered to become, in a way, developers and system owners. And the idea is that in the long run, um, you'll be able to create extremely sophisticated things.